In this tutorial, we're going to talk about the chemical composition because it is important for you to understand that most of the materials that you find in nature or any chemical process, they are mixtures of a lot of species. And when I say species, they can be atoms or compounds. The physical properties of this mixture depend strongly on the mixture composition, how this is composed. The atomic weight of any given atom is given in the periodic table. And with that, we can build up the molecular weight. So if you have H2O, remember that you have to multiply the atomic weight of hydrogen times 2 times plus the atomic weight of oxygen times 1, and then you get the molecular weight of H2O. The gram mole is the amount of substance whose mass in grams is numerically equal to its molecular weight. So let's say that if the molecular weight of carbon or the atomic weight of carbon is 12, okay, it means that 12 grams will be equal to 1 mole of carbon. We can also have the pound mole, the pound mass mole, which will mean that the 12 pound mass is going to be equal to 1 pound mass mole. So with this, we can get the amount of moles that we can have in a certain substance. If the molecular weight given, let's say the molecular weight for ammonia is 17 for ammonia, then 17 kilograms will be 1 kilomole. If we have 34 kilograms, then we can say that 17 kilograms is going to be 1 kilomole. So we will have 2 kilomole in 34 kilograms of ammonia. With this, we can define the mass fraction and the mole fraction. The mass fraction is the mass of component, whatever component A is, over the total mass. This is a dimensional. And with this, we can get the percentage. The percentage by mass will be 100% times the fraction, the mass fraction, right? So if we say that we have 5% of methane, then 0.05 is going to be the mass fraction of methane. The mole fraction, very similar, is going to be the moles that we have of A over the total moles. And with this, we can say that 100 times YA is going to be the mole percent. So if we have 5% mole of methane, we will have 0.05 is going to be YA of methane. We can pass from mass fraction to mole fraction with the molecular weights. The average molecular weight of a substance will be the composition or the mole fraction of component Y times the molecular weight of that compound 1 plus the composition or mole fraction of component 2 times molecular weight 2, etc., etc. So we are going to add up each mole fraction times the molecular weight. Very common mixture is air. So the molecular weight of air is going to be equal to, let's say we only have nitrogen, so the mole fraction of nitrogen times the molecular weight of nitrogen plus the mole fraction of oxygen times the molecular weight of oxygen. So we usually say that 79% is going to be of nitrogen, and nitrogen will have 28 kilograms of nitrogen per mole, and 21 is going to be for oxygen, and this is going to have 32 as molecular weight. So we will have 29 as the average molecular weight for air, which means that 29 kilograms is going to be a kilomole of air, or 21 pounds mass is going to be 1 pound mole. of air. Concentration, well, we can have the mass concentration, we can have the molar concentration, or we can have the molarity, which is a very particular way of expressing the concentration. So the mass concentration is going to be given as the mass of one component per the volume of the mixture. So let's say mass of A per total volume. The molar concentration would be the moles of component A over the volume, the total volume, and the molarity, which is a very particular molar concentration, is the gram moles of A or of the component A over a liter of solution.